This is the second part of my series on Martian geology. It describes the Meridini Plenum region of Mars, the landing area of the Mars rover Opportunity. This part shows the Meridini Plenum was catastrophically flooded and links this event to the major geological catastrophe described in Part 1. The twin rovers, Spirit and Opportunity, landed on Mars in January of 2004. Since then, they have sent back a wealth of data. Both rovers have found that Martian soil is largely volcanic ash. Many of the rocks they have examined are composed of the volcanic rock basalt. When Opportunity landed in the Meridini Plenum region of Mars, the scene that it showed was strange even for Mars. Not only was the soil darker than any other landing site, but the ground was covered with innumerable hematite nodules. They are evidence of water and volcanic activity. Hematite is also present in the soil, giving it its dark color. The outcropping of rocks in the crater Opportunity landed in were made of uneven layers. This type of layering shows that they were laid down by moving water. This helps provide evidence for a global catastrophe. The rocks were also strangely eroded. Some of the rocks had hematite nodules embedded within them. Some had the hematite nodules out on sticks of rock. These patterns have persisted throughout the area that Opportunity has explored. The deeper craters show deeper rocks in layers of different rocks. Chemical analysis shows that much of the rock in Meridini Plenum contains sulfates, a byproduct of the reaction of sulfuric acid and water. The Meridini Plenum region of Mars shows evidence of large amounts of water flowing into it in a catastrophic manner, including an inflow channel at one end and a splatter zone at the other end. This inflow channel has ridges that are consistent with a flow channel, and the splatter zone shows evidence of flowing over underlying terrain in a chaotic fashion, similar to the termination of a mud flow. The evidence suggests the Meridini Plenum suffered catastrophic flooding sometime in the past. The craters studied by Opportunity are blasted through layers of rock, showing that the flooding happened before these impacts. However, other craters in the area show evidence of forming before the flooding by the sedimentary patterns of the craters. These craters have sedimentary deposits up against the crater walls, and in the opposite direction of the flow of water. The flooding at Meridini Plenum seems to have originated at about 12 degrees south and 31 degrees east, based on the patterns of deposited material in the surrounding terrain. An eruption of underground water seems to be the most likely source. Underground water would be under pressure, causing it to be ejected at high velocity and resulting in the erosion of considerable amounts of material to become the sedimentary rocks found by Opportunity. However, an impacting body cannot be eliminated as a possible source since no eruption point has been found. Some of the flood water went in different directions, but most of it would have rushed downhill into the Meridini Plenum region. This water would have been loaded with material, some of which was deposited over the area explored by Opportunity. It has been shown that sedimentation and moving water can form multiple layers simultaneously. As a result, a sudden flow of rushing water could have easily laid down all of the rock layers observed in the Meridini Plenum region. The leading edge of the flowing water would have formed a splat zone, as observed in the northern part of the Meridini Plenum region. Once flooded, the water would likely have remained as long as the volcanic ash covered the planet. As the volcanic ash settled, the sulfur would have reacted with the water, forming sulfuric acid. This shows that this occurred at about the same time as the volcanic eruptions discussed in Part 1. The environment of this temporary lake would have been more like that of a car battery than an ocean. The presence of concentrated sulfuric acid would have aided the formation of the hematite spheres Opportunity found all over the area. The craters studied by Opportunity resulted from impacts that occurred while the area was flooded, and the concentrated sulfuric acid eroded the rocks, producing the erosion patterns that have been seen, including the hematite spheres on sticks of rock. In conclusion, data from both Spirit and Opportunity support a catastrophic model of Martian geology. Opportunity has shown that Mirindi Planum was catastrophically flooded at about the same time as the other catastrophic events on Mars. Mirindi Planum is not an ancient sea, and it is not an ancient habitat for life. Mirindi Planum is a site of a catastrophic flood. It has always been inhospitable to life simply because it had highly concentrated sulfuric acid.